Thanks for joining our little Mathcad webinar this afternoon, everybody. Can everyone hear me? My name is Newell and I work at Cadet and Mathcad support, and I'll be showing a general overview of how Mathcad can be used for documentation purposes as well as problem solving and graphing. If you have any questions during the presentation, you can type it into the little message box on the lower left and I'll do my best to answer. Then our directors join our session remotely. Can everyone see my Mathcad screen? Okay, so the Mathcad workspace contains a whiteboard with function-specific toolbars, which you can access by selecting any of these buttons at the top here. So I've got a calculator, graph, matrix, and many other function-specific toolbars. You can work anywhere within the worksheet by clicking on it. I'm going to start with a simple calculation. 15 take away 8 divided by 104.5. As you can see, I'm entering the text in a natural math notation. Now, by entering the equal sign, this triggers Mathcad to compute the answer. I can always go back and change that, and Mathcad will automatically update this for me. Now, this is different from the colon equal sign, which tells me that Mathcad we are assigning a value. So t, I'm going to assign it to be 10, and let us assign acceleration to be negative 9.8. And then I can use both those equations to compute the answer. So yes, the colon equal sign is telling Mathcad I am assigning a value, whereas by entering the equal sign, like I just did then, this is telling Mathcad to numerically compute an answer for me. Now, Mathcad can also be used to perform repeated or iterated calculations. So I can assign t to be from 10 to 20. Now notice the little green squiggle that has occurred underneath this t value. If I click on it, this will tell me that this expression redefines a previously defined variable. So this is Mathcad's way of error checking and letting me know that I've redefined something. Now green means it's not a critical error, but if you see a red variable, this indicates a critical error that, and Mathcad often gives you hints for you to go back and change something in order to fix that error. So I'm now going to use this within an equation. So 1,600 plus, yes, so the dot dot, so 10 dot dot to 20 here means range, so the range from 10 to 20, so 10, 11, 12, all the way up to 20. So here I've just defined a new function, and then I can go and evaluate that function by entering the equal sign, which will trigger Mathcad again to compute not only one variable, but the values for each of these variables from 10 all the way to 20. I can then use that and graph this up. So I simply clicked on my XY plot here on my graph toolbar, enter my values, if you'd like to change the increment of the range, you can simply assign the first value followed by second value, followed by the range, the dot dot up to your endpoint, and this will tell Mathcad that you want the increment to be of 0.5. So once I finish entering my x and y values, I can then click outside the graph and Mathcad will automatically graph that for me. Now let's have a look at an Excel spreadsheet. Now notice here that the spreadsheet doesn't give me much information until I actually click on a particular cell. So here I've got some information which tells me different cell references. So I'd need to know where C49 is, so there's C49. I'd then also need to know where C34, which is a little bit higher up, which is there. I'd also need to know where C35 is, which is there. I also need to know the value of K plus 11, K11, which is somewhere here, and also C23. So you can see it's very, very complicated. Now let's have a look at a quadratic formula equation. If I enter text into an Excel spreadsheet, it looks something like this. So B1 plus the square root of bracket B1 times B1 minus 4 times A1 times C1 close bracket divided by 2 times A1 there, and I can enter that, and I get an answer of 1. Now, I don't know if you can tell that that's a quadratic equation just by looking at this particular cell here. Now let's have a look. Yeah, you can't really tell anything from that. It just looks like a series of numbers and letters and a shorthand of a square root. So it's very complicated. It is quite a big mess. So let's have a look at how we could do this in Mathcad. So I'm going to define x as being b plus the square root of b squared minus 4 times a times c over 2 times a. And as you can see, this is the form of a quadratic equation that we can actually understand. Now here is like one of the critical errors. Let's have a look back at Excel. So as you can see from here, and looking at Mathcad, it's a big difference, isn't it? Here's one of those critical errors I mentioned earlier. So this is telling me that this variable is undefined. So I'm actually just going to quickly define b as being 3, a as being 2, c as being 1. And then I can evaluate by entering x equals 2, and Mathcad is going to evaluate that for me. So if I compare that again back to Excel, big difference. And the answer is indeed the same as Excel. Now, one of the newest features of Mathcad 15 is its design of experiments and functionality. So design experiments. So this looks at design matrices, factor screening plots, regression analysis, Monte Carlo simulations. Now, I'm going to be looking at one particular example of ANOVA and blocking. Now, this particular function allows us to create full factorial design matrices. So when we're looking at different factors, here. I've got a design variable here that has 4 different factors. So factors can be the conditions of the experiment, so it could be things like time, the time of day, temperature, the age of the population. So we're looking at the variations within those factors. And then they can be assigned different letters here, and here we've got different runs and different blocks. Now, the block function lets you split that matrix up into two different blocks. So we've got the first set and the second set. The randomize function lets you then randomize the runs within each set, each block. And then you can go off and do your experiments and come back and quickly enter your information, your data into a matrix here, or you can simply use the existing one that's already here. Now the quick screen function is extremely useful in evaluating the effects between different factors, the second order interactions, and the blocking. From there, yes, all of these are new functions that are available in Mathcad 15, which weren't available in the previous editions of Mathcad. From there, we can then go on to have a visual representation of this data in a Pareto plot, where it's showing that the variables or factors A, C, and D are significant. The interactions between AC and AD and the blocks are also significant. So this tells me extremely useful information in order for me to make a judgment of my experimental data. So Mathcad allows you to optimize your designs and engineering process by improving readability. It also allows for verification and error checking. It has an extensive library of calculation tools, like the tutorials and the quick sheets that I've shown you, and it allows you to generate engineering appropriate graphs, perform image analysis, matrix analysis, and provides data support. So thank you for participating in our Mathcad webinar this afternoon. Did anyone have any questions? I hope you found today helpful and enjoy the rest of your day.